What's up? Welcome to Models and Agents, episode 109. It's July 12th, 2026. The AI world never sleeps. Here's what you need to know today. New 8B retrieval models top MTEB while cutting index size 16 times, making fully offline edge RAG practical for the first time. VultronRetrieverPrime-8B leads its class on the MTEB leaderboard with dramatically smaller indexes and higher throughput than prior 9B models. BNB Agent Studio now deploys persistent agents on AWS Bedrock Agent Core. Developers continue to report that context and memory plumbing consumes the majority of their build time when working with multiple LLM providers. The Vultron Retriever family of models released on Hugging Face today. The release includes three sizes: Vultron Retriever Prime-8B, Vultron Retriever Core 4.5B, and Vultron Retriever Flash 0.8B. All three were trained on datasets with zero cross-dataset duplication or eval contamination. Prime-8B delivers up to 16 times smaller index storage and 12 times higher throughput than previous 9B class leaders, while ranking first on MTEB. Core 4.5B outperforms models twice its size. Flash 0.8B runs fully offline on edge devices and indexes up to 60 images per minute. The models use the Hydra architecture for late interaction retrieval at high precision with generation at roughly half the memory of comparable systems. This open weight release continues the tracked narrowing of the open versus closed performance gap, with the zero contamination training data directly addressing one of the key open questions around eval integrity. Builders working on offline or resource-constrained RAG should test these immediately for embedding and retrieval workloads. Watch for community fine-tunes and integration into existing vector pipelines over the next week. Thinking Machines Lab published an essay titled "The Future Worth Building is Human." The piece frames human participation and model ownership as technical problems solved through decentralized alignment and interaction models. It highlights Tinker's LoRa fine-tuning approach that lets teams train and retain their own model weights rather than relying on shared frontier checkpoints. Builders focused on domain-specific adaptation should experiment with the LoRa workflow described to keep weights private and auditable. The founder of ZPU publicly advocated prioritizing open-source models over restricted frontier systems. The statement argues that openness accelerates progress more effectively than closed development. Teams evaluating licensing terms should factor this stance into decisions about whether to standardize on fully open families such as Qwen or DeepSeek. The comments reinforce the view that restricted access slows collective iteration on core capabilities. Sam Altman noted that multiple benchmarks position 5.6 Sol as the current strongest model. He highlighted physician preference for its responses over human-written ones in flaw detection. The comments continue the frontier model cadence discussion from yesterday without new release details. Watch for any follow-on announcements on cost or availability. This update keeps the tracked frontier release cadence visible, while physicians' reported preference for GPT 5.6 responses adds a concrete capability signal on medical text quality. BNB Agent Studio now launches autonomous agents that run continuously on AWS Bedrock Agent Core. The platform supports quick deployment of agents that persist beyond single sessions. Developers building long-running agent workflows gain a managed path that avoids custom orchestration code. Early users should verify sandbox constraints before routing production traffic. This deployment option advances the tracked question of long-horizon agent reliability by providing a hosted runtime that removes the need for teams to maintain their own persistent execution layer. A 4-agent Crew AI system for literature reviews adds explicit claim-level citation verification with a 6-class support taxonomy and confidence-gated escalation. The pilot achieved 100% citation metadata validity in ablation conditions without the editor pass. The full system flagged 23% of 291 citations as unsupported. The editor-to-writer revision loop was not exercised in the pilot, so the work functions primarily as a detector rather than a self-correcting pipeline. Researchers needing verifiable citations should examine the released reference implementation and its 72 automated tests. The framework's asymmetric evaluation highlights the value of the verification layer even when full self-correction remains untested. Builders report that memory persistence, rolling vector DB setups, and multi-model routing now dominate development time over core product logic. Common pain points include session-to-session context handling, painful provider switches, and production retrieval failures. The thread surfaces concrete questions around third-party tools such as Mem0 or LangChain memory versus custom stacks. Several developers describe spending the majority of their engineering effort on the plumbing layer rather than domain-specific features. The NVIDIA tile-based GPU programming guide walks through CU tile and Triton kernels on Colab hardware. It implements vector addition, fused GELU, row-wise softmax, tiled matrix multiplication, and flash attention with direct PyTorch comparisons. It provides a fallback path when the Q-tile stack is unavailable. Practitioners optimizing inference on NVIDIA hardware should run the Colab workflow to measure tile size trade-offs for their specific models. The guide demonstrates each kernel against equivalent PyTorch baselines so readers can quantify the arithmetic intensity gains on their own hardware. A deterministic pruning layer removes redundant tokens from growing prompts while preserving dependencies. The approach cuts token usage and latency without quality loss and is backed by production benchmarks. The approach targets the common failure mode where models degrade from remembering too much rather than too little. Teams running high-volume chat or agent sessions should test the layer against their current context window strategy. The layer's deterministic nature ensures no hidden non-determinism is introduced into downstream generation. AI coding tools hallucinate plausible but non-existent package names at rates between 3.59% for GPT-4o Turbo and 13.63% for the best open source model tested. Proprietary models show roughly 4 times lower hallucination rates than open source ones in the 30-model study. The analysis examined 576,000 code samples and 2.23 million packages across 30 systems, confirming that hallucinated names are consistent enough for targeted registration attacks. Developers using AI assistants for dependency suggestions must add registry validation steps before committing code. Okay, let's pop the hood on tile-based GPU execution. Everyone talks about just using the GPU as if the hardware automatically maximizes throughput. In practice, tile-based execution forces the programmer to treat memory access as the primary constraint rather than arithmetic throughput. The core move is to load an entire tile of data into fast on-chip memory, perform all possible compute on that tile, then write results back. This eliminates repeated round trips to high-latency HBM and explains why tiled matrix multiplication and flash attention show large speedups once tile sizes exceed roughly 128 by 128 elements. The trade-off appears immediately in register pressure. Larger tiles improve arithmetic intensity but can spill registers and reduce occupancy, with the crossover point varying by architecture and kernel. On consumer cards, without the full Q-tile stack, the same logic still applies through Triton, though you lose some automatic scheduling. Use tiles when your working set fits in shared memory and you can fuse multiple operations. Fall back to standard kernels when the data is too sparse or the launch overhead dominates. The gotcha that bites most teams is choosing tile dimensions once and never retuning them when model width or batch size changes. Retuning becomes especially important when moving from training to inference workloads where activation shapes differ markedly. Grab VultronRetrieverPrime-8B from Hugging Face and benchmark it on your current retrieval workload to measure the 16 times index size reduction. Run the MarkTech Post Colab notebook for tiled matrix multiplication and flash attention to see concrete speedups on your GPU before committing to custom kernels. Add a simple registry existence check before accepting any package name suggested by an LLM coding assistant to guard against slop squatting. Test the deterministic prompt pruning layer on a long-running agent session to quantify token savings versus your current context strategy. Continued community testing of the Voltron Retriever Hydra architecture on edge devices is expected. Potential follow-up from Thinking Machines Lab on open tooling for decentralized alignment is on the way. More developer reports on multi-model routing and memory persistence as the Reddit thread evolves should appear soon. Further analysis of slop squatting vectors as open source model usage grows will likely surface next. Tomorrow, keep an eye on community fine-tunes of the Voltron Retriever models and any new edge device benchmarks. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at Nara Network. Links in the show notes. And before you go, this show is part of the Nara Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. First Principles Daily, reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. Find every show free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com/gallery. Royalty-free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.